Okay, here we go. We're going at light speed now. Please, you can control how fast I go in the playback speed. If you go into YouTube and click on playback speed, you can set me to I think 0.75 speed, 0.5 speed, 0.25. I think my voice gets lower and maybe a bit more scary and demonic if you do that as well. So maybe that's fun. Here we go. For some angle theta in standard position, if the cosine ratio is root 15 over 3 in quadrant 2, determine the tangent ratio for that angle. Okay, so let's give this a shot. We have a bunch of information. We know that the cosine, sorry, not the cosine, the cosecant ratio for angle theta is really just root 15 over 3. By the way, keep in mind, at no point in any of this process are we ever actually going to have to solve for theta here. We actually don't need to know what the specific angle is. We could find it with a calculator, but we don't need it. So we have the cosecant ratio, and the cosecant ratio is really just, remember, cosecant is really just 1 over sine. And because sine is y over r, the cosecant ratio is just going to be r over y. So r over y is root 15 over 3. Alrighty. Okay, so we have this this bit of information, which is actually pretty important. We can say that when we have a y value of 3, the corresponding r value is root 15. Okay, so that's going to be important information because then we're going to be able to leverage the Pythagorean theorem to find out what x then must be. And we will do that. I just want to draw a picture first. So we have some angle. It ends or terminates in quadrant 2. Just drawing some random angle in standard position on a coordinate plane. And this is the terminal arm. This is the terminal arm. Okay. And maybe this is the point. This is the point that we're interested in. We don't know the corresponding x coordinate, but the y coordinate is 3 when we have a r value of root 15. Okay, so let's then find the corresponding x coordinate, right? Because we know that this triangle has a height of 3 and its hypotenuse is root 15. So let's find the x coordinate. So x squared equals r squared minus y squared. So just a little bit of algebra there, just rearranging the formula. And so we're just going to have, and then we're going to take the square root of that. So what is r? R is root 15. So we're going to have root 15 squared. We don't need a calculator for that. It's just going to be 15. And then y is 3, so we're going to square that. So we really have the square root of 15 minus 9. And this is just going to be the square root of, well, what is 15 minus 9? It's 6. So x, so x is square root of 6. Now here we might think, x is square root of 6. That's a strange value for an x coordinate in quadrant 2 because x coordinates in quadrant 2 should be negative. And here's how we can make sense of this. Here, if we have this statement, x squared equals r squared minus y squared, really, algebraically, what we have to do is we have to take the square root of both sides. So we take the square root of both sides, but when we're doing this, technically what we have to do is we have to take the positive and negative versions, right? And when we do this, we could have a positive answer or we could have a negative answer. So that's where the information from the question comes in. We know that this particular terminal arm, it lies in quadrant 2. And because this particular terminal arm lies in quadrant 2, we don't take the positive version of that square root. We'll only take the negative version. So in each of these cases, we're dealing with, instead of the principal or the positive root, we're taking actually the negative root because this is a terminal arm that lies in quadrant 2 where x must be negative. Okay, so that is definitely something that I usually forget when I'm doing something like a test, and small errors eventually make big waves later on in some complex questions that you end up doing in trigonometry. And if I make a mistake, that is often where it is. All right, so where were we? We want to find tangent of theta. We know tangent of theta is really just y over x. In this particular case, we know that y is, y is 3. Y is 3 when x is negative root 6. There we go. So that's tangent of theta. You might have a strict math teacher who says, hey, we have a radical in our denominator. You need to rationalize that denominator. So I'll show you how to rationalize this denominator for strict math teachers. So if we have 3 over negative root 6, I'll just put the negative out in front. If I want to rationalize this denominator, here's what I can do. I can just multiply it by itself. So I can multiply this denominator by itself. Root 6 times root 6 is just going to be 6, so it's going to be rational. But I'm only really allowed to do this to fractions if I also multiply the numerator by the same quantity, right? That way, I'm scaling up the numerator just in the same way that I'm scaling up the denominator, so I'm really not changing the ratio. I'm really not changing the value of the fraction. So this is going to be negative 3 root 6 over root 6 times root 6 is just 6. Hey, we have a common factor on the top and on the bottom. They both have a factor of 3. Let's divide out that factor of 3. So divide out the factor of 3 on top, we're just left with root 6. Divide out the factor of 3 on the bottom, we're left with 2. And there is the final answer in beautiful final form, in simplest form, because the denominator is rationalized, right? We don't have an